I started jumping on Docker. I think we all remember we went from physical to virtual machines, and that kind of jump, and how it took a little while to get used to it, but we can't live without it now. Docker seemed to be the next generation of this stuff. And my challenge was I was going out and looking at all the more advanced features of jBASE that really sets jBASE aside. And my challenge was, especially in the middle of the whole process, I had to get a new laptop. And if anybody's got a new laptop, you know that experience of getting everything reloaded. So I finally started looking at Docker's closer because it said it was supposed to help with that stuff. And I was quite impressed. And I will tell everybody here that I'm maybe now 3 months into playing with Dockers. And my focus was predominantly on development and testing out new technologies and then sharing it with my team members. But we also discussed that Dockers is really what seems to be the future of how we deploy our applications. But real quick, what is Dockers? Dockers are really, the correct term is containers. And Docker is the most widely used container type. And containers are just a little like virtual machines, but it's within this new format. Where it's different from virtual machines is it focuses on the application and not the operating system. They're much more lightweight because they actually reuse the operating system over and over again when you launch up your Dockers. And so everything you're copying around and everything you're launching and running and resources that are running are really just your application, and it reuses the Linux operating system underneath over and over again. So you're not copying that around. So your image sizes are a lot smaller and your resources are a lot smaller. Just like virtual machines, they run on all the platforms. So you can install Docker for Windows, Linux, Mac. Azure has their Docker implementations. I believe AWS has their Docker implementations. The whole goal here is to really get you to focus on your application. It's really tied into the whole DevOps concept of explaining your platforms and allowing sysadmins to easily deploy your applications versus these monolithic black box, please don't touch it and break it situations we quite often have with our PIC systems. Again, the focus is to improve the speed to deploy and test. It's very focused on cloud because that's how cloud wants to work. And as I said, it's very DevOps friendly. So your admins and stuff will really like it. This little slide I threw out kind of shows the difference between a Docker and a virtual machine. Docker's on the left, your classic virtual machine is on the right. And you can see the big difference is that the host operating system, or the Docker running Linux, is reused. Whereas with virtual machines, we have a hypervisor and we boot up a complete separate environment each and every time. Some terms you might hear out there, Kubernetes or Swarm, Mesos out there. These are technologies on really what would be if you're going to deploy your application, and they're what's called the orchestration piece. So, if you're really going to deploy your application out, there will be a whole scripting language. And some older versions of this stuff that wasn't Docker based was your Puppets and Chefs out there, which helped with deployment of machines. These are the technologies that each one of the different platform people have to help say, hey, you're going to deploy out an entire multi-machine application with let's say an HA proxy running 2 database servers in the back end with 6 web servers. These are the whole orchestration scripts to then deploy your Dockers. But in all these cases, they're still working with your Dockers. So if you're wanting to use the Kubernetes orchestration software, you'd be having to learn that script one. I'll give a quick little demonstration here of Docker Swarm, which is built into the Docker platform, and I can demonstrate it launching up a little network here on my own laptop. Where's Docker adoption coming? As I said earlier, I remember the time it took us to get virtual machines accepted and going, and I can tell you that I'm seeing and feeling the same thing with these Dockers. They are taking off, and legacy apps such as our PIC applications are the tough ones to put into this, but jBASE is well positioned with its native mode to work well on these platforms. Your application may have challenges, but the actual tech is not a challenge. And my last slide when I was talking about, hey, what can you use it for today? Again, I use it heavily, like I said, to test new technologies, share my configurations. Zumasys as a vendor, big goal of mine was to be able to show off the stuff we can do, our JEDIs to ODBC and our J remote file, which is kind of clustering configurations. I want to be able to demonstrate those and have you guys be able just to download a quick Docker image and have it up and running in a few minutes on your laptop. And another big thing is when you're deploying the applications, it really seems to be Microsoft's strategy with this technology to say you can actually still use a Windows machine as your server, but you can run your Linux version of your application, and it's pretty seamless. And you'll see that when I'm demonstrating it from here next. It's just they make it very seamless where you can jump back and forth between the two worlds, which is not something you could do with the virtual machines. You had to spawn a virtual machine up, spawn up the telnet or secure shell, then bring a PuTTY and go run into it. And then for me, because I said I went through a laptop upgrade, it was a very easy way for me to save my work. And within 20 minutes of me having my new laptop, I had my old Docker virtual machine up and running again and was continuing to do my work. Docker is completely a command line tool, so any of your Linux guys will be super comfortable with it. I'm sitting here on my Windows laptop, and it's a Docker command, and you have two technologies, two terms that are very important with Dockers. You have what's called images, which is, think of those as your templates. Like if you're in the VMware world, it would have been your templates that you would usually build virtual machines off. These are our Docker images. There's a whole store called Docker Hub, which is kind of think like Git for these Docker images, and all the different vendors have images out there. So if you are, for example, wanting to play with the latest PowerShell for Linux, already up and running, you can go right here and download a Docker image from Microsoft. I'm doing a Docker pull, and this is pulling an image from Microsoft. I love the concept behind Docker is a diffing system where it's actually layering the differences of the work you're doing on top of a core image. And that's how they keep their size down pretty small. So as this is downloading, I'm going to show you when we're talking about where we're going is as a vendor, and there's already a few people who had done some jBASE images, but see, we've got ourselves now as a vendor, and here's our base Docker image ready for anybody to pull and have an up and running jBASE system on their laptop. So hopefully this other one's done. And so I've just pulled down a Microsoft image. Now, what I want to do is I want to shoot into jBASE stuff and explain what we're doing here. Is that what I did to get started on this is I pulled a Centos image, which you'll see right here. The whole image is only 202 megs, significantly smaller than if you were dealing with a Centos virtual machine. I then brought up that image, installed jBASE with all its requirements, and then did a commit and created a new image called jBASE base, which is now about 590 megs. So it's 2 to 3 times the size of the original image. But I had to install GCC, jBASE, and all its requirements. And now I can go here, and what you do is these images are, like I said, templates. Containers are your running virtual machines. So I'll actually take a template and fire up a container. And the command is Docker, and it's run. It has a couple cryptic switches. I'm going to give it a name called one, because you reference your containers afterwards on what you name them. I'm going to tell it to run jBASE base. And that fast, I've now got a running container. I'm on my Linux machine, on my Windows machine, but I'm sitting it now with my Linux prompt as root in that container. I did a couple CPUs, that's all configurable. and it is a up and running jBASE environment. So I can and everything works. So that's the big piece, you know, where the real power, and you can see the simplicity of Dockers. Any one of you guys could right now do those 3 steps I just did, and this quickly be in and running on a jBASE environment. Now, as soon as I exit out here, the image is gone because of the way I launched it. If I want to run it as a background service, I just put a -D on it. And what it tells me is I've already used that name, so I'm going to call it 2. And it fires up a container, but this time it's running in the background versus right here on my line. So now if I do a Docker container list, and this is kind of like in your VMware saying, hey, what's my list of virtual machines? It'll show all the Docker images I'm running. And here's the one I just fired up. And you can see I already have 3 other ones where I'm testing a jBASE 5.2 image on my same machine. Another 5.7.2 where I'm doing some performance testing. If I don't name my image, it will create its own names for you. And there are these goofy names they come up with. And now I can get into my container at any time by saying docker exec, the name of my container, and any command I want to run in that container. And in this case, I'm going to say run bash. So now I've jumped into that container right here from my prompt, and I can now do all that same stuff we were doing. So those are 2 ways you launch a container. One is a real quick, just go in and test something and kick back out. Here it is, almost like a virtual machine. I fired it up. It's running in the background, just like a standard virtual machine. But here's where the big power is, guys, is that I can sit here now and say, I want to fire up another one. And that fast, I have now created another jBASE instance. And completely separate jBASE, up and running, activated, working just fine. And this is where the big power, guys, where I was really looking for this product, because I'm like, hey, I got to do all this testing where I need multiple jBASE machines to test things like 2 jBASE boxes talking to each other, possible cluster configurations. This quickly on my machine, I've got these things up and running. And when you run Docker stats, you can see the machines are using very little resources. From your network guys, it creates its own natted network. So they're all running within their own network. I can sit here and do a Docker inspect. It kicks out a big JSON string of everything about the machine. That's why I said it's very DevOps friendly. And usually I use this to find out what IP address I gave it. And it's in this special network. And it's natted off, and all those machines can talk to each other, but they're isolated off, running by themselves. So again, thank you for watching, and have a great day.